Okay, so we are on chapter 6.5, Properties and Applications of Matrices. Not a terrible chapter section at all, pretty easy, so here we go. Our goals are to learn matrix notation, learn how matrices are used in social networks, find sums, differences in scalar multiples of matrices, find matrix product, and possibly use technology. Matrix notation. So it depends on the textbook, but matrix notation is simply written as row, comma, column. And so if I'm talking about an element, so these are called my elements, and I say I'm looking at element A12. Well, element A12 would be this one because it's in row 1, column 2. Okay, that's just pretty much it. You are listed as row, comma, column. So it's the matrix name, row, column. And again, you don't have to, well, not again here. As you can see, you can do it without the commas. Okay. Some elements are also used with the lowercase letter, so it may be A row column or lowercase b row column, doesn't really matter. The letter is just telling you what matrix it's to look at or identify from. So for example here, this says identify element A12. So element A12 would be -1 because it's in row 1, column 2. This one says identify B32. So I'm going to go to matrix B, row 3, column 2. Matrix B, row 3, column 2 is -2. Okay, B22. Again, I'm going to go to matrix B, row 2, column 2, and that's going to give me 6. Okay, so this is now just kind of combining your ability to identify and to add. So it says here you're going to compute A11 times B11 plus A12 times B21 plus A13 times B31. So A11, I'm going to go to A, row 1, column 1, and I get 0 times B, row 1, column 1 is 0 plus A12 is -1 times B21 is 2 plus A13, that's going to be 6 times B31, that's going to be 7. And that's going to give me -2 plus 42, which equals 40. Pretty simple, right? And it says find a value for x that makes a equal to b. So if I wanted these to be equal, what would x have to be? Well, x, look at the locations that they're in. X would have to clearly be 6. So x would need to equal 6 in order for a to equal b. Okay? Oh, wait. Sorry. It wouldn't matter because 9 and 7. A31 and B31 does not equal. So not possible. Not possible because A31 does not equal B31. Gotta pay very close attention. Matrix addition and subtraction only works if the dimensions are the same. That means the rows and columns are the same. And you add and subtract matrices element by element. Okay, and the result, we just call it matrix C. So if I have matrix A plus matrix B, I'm going to produce matrix C. And you're literally going, what's 1 plus 5? 6. What's 3 plus 2? 5. What's -2 plus -1? -3. Okay? Subtraction is working the same. What's 4 minus 1? 3. What's 2 minus 4? -2. What's -1 minus 2? -3. And you just keep going. Okay? Element by element. That is how it's computed. So let's look at some examples. If I'm doing A plus B, I'm going to make matrix C, which is going to equal 4 plus 3, 7. Negative 1 plus 3, 2. 4 plus 1, 5. Negative 5 plus 0, negative 5. 1 plus negative 2, negative 1. 0 plus 4, 4. And that's it. As simple as that. Okay? Let's look at b plus a. So now we're doing b plus a. And that's 3 plus 4, 7. 3 plus negative 1, 2. 1 plus 4, 5. 0 plus negative 4. Negative 2 plus 1, negative 1. 4 plus 0, 4. Notice how we get the same result as we did in example 3a. And that's because matrix addition is commutative. A plus b is going to equal b plus a. All right, a minus b. So 4 minus 3, 1. Negative 1 minus 3, negative 4. 4 minus 1, 3. Negative 5 minus 0, negative 5. 1 minus negative 2, negative 3. 0 minus 4, negative 4. Element by element. That's all you have to do. Okay? Oh, scalar multiplication. So that means you're multiplying the matrix by one number. So every element in the matrix is going to be affected. It's basically the cousin of distribution. Okay? So I'm going to multiply 2 to element A 1, 1, 2 to element 1, 2, 2 to element 2, 1, 2 to element 2, 2. And so, boom, I get my result. That's my new matrix. Okay, let's try some scalar multiplication. Negative 2. So I'm going to multiply every element times negative 2. So I'm going to call this matrix B. Matrix B is going to equal 2 times negative 2, 0 times negative 2, negative 1 times negative 2, negative 3 times negative 2. Negative 3 times negative 2, 3 times negative 2, 6 times negative 2. Then we have negative 1 times negative 2, negative 4 times negative 2, and negative 3 times negative 2. Okay? And then we do the math, and that's your solution. So when we do the math, we have negative 4, 0, positive 2. Positive 6, negative 12. We have 2, 8, and 6. Bam. Scalar multiplication with matrices. Okay? So just putting it all together, to make sure that it's possible, you want to make sure that A and B have the same number of rows and columns. So the dimensions here are 2 by 3. The dimensions here are 2 by 3. So that means you can proceed to solve for C. So 1 plus 0 is 1. 3 plus negative 3 is 0. Negative 2 plus negative 1 is negative 3. Negative 4 plus 1 is negative 3. 5 plus negative 5 is 0. Negative 1 plus 2 is positive 1. Bam. Okay. 3 times A. Can I do that? Why, yes, I can. It's just a scalar times each element. So C equals, and it's going to be 3, U times 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 3. Okay. And so that gives me 3, 9, negative 6, negative 12, 15, and negative 3. Okay. Now, getting a little more. So we're going to have scalar multiplication combined with subtraction. Just like when you have PEMDAS, what do you do first? You're going to do the multiplication and then the addition and or subtraction. Okay, we're going to do the multiplication first and then the addition and or subtraction. So I'm going to multiply first, and when I multiply, so I'm multiplying everything in this one by 2 and everything in this one by 3. Okay, so I'm going to write it all out. So I'm going to have 2 times 1 minus 3 times 0. That's my first new element, right? And then I'm going to have 2 times 3 minus 3 times negative 3. And my next one's going to come from negative 2. So I have 2 times negative 2 minus 3 times negative 1. Then I'm going to have 2 times negative 4 minus 3 times 1. Then I'm going to have 2 times 5 minus 3 times negative 5. And then last but not least, I have 2 times negative 1 minus 3 times 2. And now I'm going to do the math and find my C. 2 times 1 is 2, minus 0 is 2. 6 plus 9 is going to give me 15. Negative 4 minus negative 3 gives me negative 7. Negative 8, it's plus 3. Negative 4 plus 3 is going to give me negative 1. Negative 8 minus 3 gives me negative 5. 10 plus 15 gives me 25. Negative 2 minus 6 gives me 4. Okay, so PEMDAS applies. And if you do not want to do it in one full step, you can do it in 2. You can multiply, and then add or subtract. Okay, matrix multiplication. So matrix multiplication is a little different as well. With matrix multiplication, a couple things have to be true. The rows and columns are different for most of them, but so let's say I have matrix A and I have matrix B, and the dimensions of matrix A are row 1 by column 1. And then here we'll have these R2 by column 2. Okay? The number of columns in matrix A has to equal the number of rows in matrix B. I call it has to make a smile. If it's not the same, then it will not produce. There's no product. Okay? The rows in column A and the columns in column B are going to be the rows and column of your product matrix. So if we look here at the example, matrix A is a 4 by 2. Matrix B is a 2 by 3. Notice how the columns and the rows are the same. It's happy. And the outside make up the dimensions of the product, which will be a 4 by 3. Okay? Now, if you look here at matrix C and matrix D, matrix C is a 4 by 2 matrix, and matrix D is a 3 by 5 matrix. Sad day. The columns and the rows of matrix C and matrix D are not equal. And because that's not true, then there's no product. So there would be no product between C and D. Okay. Matrix multiplication. matrix multiplication is row times column plus row times column. Each element, I'm sorry. Each new element is a row times a column. Then the next element, the row times the next column. And then the next element, row, column, row, column. And you're adding the product of the row times the column. So let's look at it with numbers. So here, I'm going to check that they work. So I have a 2 by 3 and a 3 by 2. Oh, they're smiling. It works. So they're going to have a product, and the product is going to be a 2 by 2. Okay, so to find my product, I'm going to multiply each element. It's the sum of the product of each element in the row A, and column B. So 1 times 6 plus 2 times 5 plus 3 times 4 is my first element. And then I do the next one. 1 times 3, 2 plus 2 times 2 plus 3 times 1 is my second element. Next row, 4 times 6 plus 5 times 5 plus 6 times 4 makes my third element. 4 times 3 plus 5 times 2 plus 6 times 2 makes my fourth element. And that's the pattern. All right, each element should be multiplied by another element twice in this situation. And as you can see, like I said, I will end up with a 2 by 2 as my product matrix. So let's go in. Let's dive in. So if possible, find A, B, and BA. So first thing you got to do is determine the dimensions. So the dimensions here are 3 by 3 and 3 by 2. If I am doing A times B, that is possible because my columns in my first matrix are equal to the rows in my second matrix. And so I'm going to produce a 3 by 2 matrix. Okay, now B times A. B times A, which means I would have a 3 by 2 and a 3 by 3. Sad day. The columns in my first matrix does not equal the rows in my second matrix. So therefore, this is not possible. I'm going to do the one that is possible. Okay, so I'm going to do my very best to change the colors so that you can see where they're going. I need to make that a little longer because I'm making a 3 by 2. All right, so I'm going to take the elements in this row and multiply them to the elements in this column and add the sums together. So I have 2 times 1, 1 plus 1 times 2 times 2 plus negative 1 times 3. And that's my first element of my 3 by 2 that I'm producing. I have 5 more elements to find. Okay. Uh-oh. Make it yellow. Okay. So we're going to go again. So now I'm going to do 2 times 1, 2 times 1 plus 1 I'm sorry, I'm not on 1, I'm on 0. 2 times 0, you saw nothing. 2 times 0 plus 1 times negative 1 plus 2, I'm sorry, plus negative 1 times 1 plus negative 1 times 1. All right, I'm entirely too worried about the colors, but I wanted to do the colors on the first go around so that you can see where they're coming from. So the white were coming from my row, and the yellow were coming from my columns. So row 1 of matrix A produces row 1 of matrix A times B using the columns of matrix B. All right, so now I'm not going to switch colors. I'm just going to write it out. So we have 0 times 1, 0 times 1, plus 2 times 2, plus 2 times 2, plus 1 times 3. 1 times 3. That's the first element in row 2. I have another element to find. So we have 0 times 0 plus 2 times negative 1 plus 1 times negative 2. I mean, 1 times positive 1. Okay, then our last one. So we're now on row 3, which is going to make our last row in our matrix product matrix. So we have 3 times 1 plus 2 times 2 plus negative 1 times 3. Okay, and our last element, we have 3 times 0 plus 2 times negative 1 plus negative 1 times 1. And finish it. Okay, so if you guys look, you can see a pattern, hopefully. You see it. So if you want to check yourself, look and see that the elements in each one are being used the number of times of the rows, of the columns, and of the rows. So notice here, 1s, 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 yes. 2s, 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 yes. 3s, 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 yes. 0, 0, 0, negative 1, negative 1, 1, 1, 1. So I use these values, and they're all there and present. All right, so we're going to write our product matrix. I'm going to write it here up the top because I don't have any more room. So A times B equals 2 plus 2 is 4, minus 3 is 1. 0 minus 1 is negative 1, minus 1 is negative 2. Okay, 0 plus 4 is 4. 4 plus 3 is 7. 0 minus 1 is minus 2 is negative 2. Negative 2 plus 1 is negative 1. 3 times 1 is 3, plus 4 is 7, minus 3 is 4. 0 minus 1 is negative 1. Negative 1 minus 1 is negative 2. And there's my product matrix. Okay, product matrix definitely take a little more time. Okay, here we go. So you're going to determine if it's possible. So this matrix is a 2 by 3. This matrix is a 3 by 2. So if I'm doing A times B, that's going to work. It's a smile. Whoop, whoop, whoop. If I do B times A, is that going to work? So that would be a 3 by 2. 3 by 2 times a 2 by 3. Uh-oh, look at that, look at that. Love is in the air. It works again. Happy faces for everyone. Okay, so that means I can find both of them because it works. So when I find the product of AB, the result is going to be a 2 by 2. So I'm going to create a 2 by 2. I have -1 times 2 is -2, plus 0 times 5 is 0, plus -2 times 0 is 0. And then my next element, -1 times -2 is 2. 0 times -1 is 0. -2 times 1 is -2. Then my next element, 4 times 2 is 8. -2 times 5 is -10. 1 times 0 is 0. 4 times -2 is -8. -2 times -1 is +2. 1 times 1 is 1. I'm going to clean this bad boy up. And I have -2. I have 0. I have -2. And I have -5. Okay, now I'm going to do B times A. So BA equals, now I'm doing 2, the row times the column. The row times the column, which means I'm producing a 3 by 3. Okay, so I have 2 times -1, which is -2, plus -2 times 4, which is -8. Done with that one. Now I have 2 times 0, which is 0, plus -2 times -2, which is 4. And then I have 2 times -2, which is -4, plus -2 times 1 is -2. Then I go again. 5 times -1 is -5, plus -1 times 4 is -4. 5 times 0 is 0, plus -1 times -2 is 2. 5 times -2 is -10, plus -1 times 1 is -1. Last row, 0 times -4, -1 is 0, plus 1 times 4 is 4. 0 times 0 is 0, plus 1 times -2 is -2. 0 times -2 is 0, plus 1 times 1 is 1. And so B times A equals -2 plus -8 is -10. -5 plus -4 is -9. 0 plus 4 is 4. 0 plus 4 is 4. 0 plus 2 is 2. 0 plus -2 is -2. -4 plus -2 is -6. -10 plus -1 is -11. And 0 plus 1 is 1. And that would be your B times your A. All right. Last one, I think, and then I have one more just for you to do. If I have A times B, well, I have a 3 by 3 and a 3 by 3, so obviously it's going to work, right? Because I have two 3 by 3s. So I'm going to split my space in half so I can do this correctly. Remember, it's the elements of the row times the elements of the column added together is your first element. of your product matrix. Elements of the row times the elements of the column, elements of the row times the elements of the column. Okay? So we're doing A, B, and because we have 3 by 3 and a 3 by 3, oh, we're happy, it's going to work. Oh, we're happy, and my product is going to be a 3 by 3. Okay? So we have 1 times negative 1 is negative 1. We have negative 2 times negative 3 is positive 6. We have 5 times 5 is 25. Element 1 done. That was first row, first column. Now I'm going to do first row, second column. Negative 1 times negative 4, 1 times positive 4 is 4. Negative 2 times 0 is 0. 5 times 1 is 5. That was my second element. Then my third element, it's going to be 5 times 2 is 10. I'm going to squeeze it in there. I didn't give myself a lot of room. Is 10. Negative 2 times 1 is negative 2. 2 times 0 is 0. Make that prettier. Plus negative 2. That is not a negative 2. Let me just write minus 2. Minus 2 plus 0. All right. So first row is complete. So now I'm going to go on to the second row. All right. So 1 times negative 1 is negative 1. 0 times negative 3 is 0. Negative 2 times 5 is negative 10. 1 times 4 is 4. 0 times 0 is 0. Negative 2 times 1 is negative 2. 1 times 2 is 2. 0 times 1 is 0. Negative 2 times 0 is 0. Last one. 1 times negative 1 is going to give me, I'm sorry, I'm on 2, sorry. No, I'm all right. I forgot where I was. 1 times negative 1 is negative 1. 1 times negative 3 is negative 3. So you know I'm tired now. 3 times negative 3 is negative 9. 2 times 5 is 10. 1 times 4 is 4. 3 times 0 is 0. 3 times 1 is 3. Okay? Where am I at? 2. No. 1 times 2 is 2. 3 times 1 is 3. 2 times 0 is 0. And I get negative 1 plus 6 is 5. 5 plus 25 is 30. Negative 1 plus 0 is negative 1. Minus 10 is negative 11. Negative 1 minus 9 is negative 10. Negative 10 plus 10 is 0. 4 plus 0 is 4. 4 plus 5 is 9. 4 plus 0 is 4. 4 minus 2 is 2. 4 plus 0 is 4. 4 plus 3 is 7. 10 minus 2 plus 0 is 8. 2 plus nothing is 2. 2 plus 3 is 5. 5 plus 0 is 5. So there's my product matrix. Okay, now to find B times A. So again, I'm going to produce another 3 by 3, but this time I'm going this row times this column. Okay, so let me erase my dots. I have the same dots. All right. So I'm doing negative 1 times 1 is negative 1. 4 times 1 is 4. 2 times 1 is 2. First element complete. -1 times -2 is 2. 4 times 0 is 0. And 2 times 3 is 6. Second element completed. -1 times 5 is -5. 4 times -2 is -8. 2 times 2 is 4. Third element done. Second row, second element, second row of elements and product. -3 times 1 is -3. 0 times 1 is 0. 1 times 1 is 1. -3 times -2 is 6. 0 times 0 is 0. 1 times 3 is 3. Okay? -3 times 5 is -15. 0 times -2 is 0. 1 times 2 is 2. Last row. 5 times 1. So 5 times 1 is 5. 5 times 1 times 1 is 1. 0 times 1 is 0. Okay? And then we have 5 times -2 is -10. 1 times 0 is 0. 0 times 3 is 0. -5 times 5 is -25. 1 times -2 is -2. And 0 times 2 is 0. So we have -1 plus 4 is 3. 3 plus 2 is 5. 2 plus 0 is 2. 2 plus 6 is 8. -5 minus 8 is -13. Plus 4 is -9. -3 plus 0 plus 1 is going to give me -2. 6 plus 3 is 9. -15 plus 2 is -13. 5 plus 1 is 6. -10 plus 0 is -10. -25 minus 2 is -27. Plus 1 is -26. And those are your products. Okay? All right, the last one here coming up. When we check it, we have A times B. So our dimensions here are 3 by 3 and 3 by 1. So if I was to do A times B, good to go with a matrix of a 3 by 1, right? If I was to do B times A, I would have a 3 by 1 times a 3 by 3, which is a sad day. So it would be no product. Okay, so you can find A times B, but you cannot find B times A. So A times B would equal, and I'm going to end up with a 3 by 1. So I have 6 times 10 is 60, plus 1 times 20 is 20, plus 0 times 30 is 0. Then I have -2 times 10 is -20. 5 times 20 is 100. 1 times 30 is 30. 4 times 10 is 40. -7 times 20 is -140. 10 times 30 is 300. So my product is 80, and then 110, and then we have 400? No, 200. And that would be my product. Do I have a 3 by 1? I have a 3 by 1. Okay, this last one is for you to try. Try it on your own. It's a 3 by 3. I have included the process for you to check if you want to come back and check yourself. But then you continue. But it's all written out so that you can see the pattern and you can see how you can double check yourself. If you need to write it out completely, do not try to feel like you have to do the math in your head. That's what this is here for. Let me know if you have any questions. Thank you.